Hey, Nathan here. Welcome back to another video game algorithms video. In the last video, we discussed how to hide an object from an enemy by utilizing boxes or some kind of obstacles in our environment to use to be between ourselves and the enemy. This video, we are going to discuss a useful addition to that, which is field of view. In order to determine if your player object needs to hide from an enemy object, we need to use field of view. We can visually see in this example that we do not need to hide because this object is way too far away where it can't even see the enemy. So let's discuss field of view. So let's say we have an enemy here, and the enemy is going to point upwards in this example. So our enemy is here. So that's our enemy. And our player is going to be here. So that's our player. There's two approaches we can take with field of view. They both share the very basic concept. So I'll discuss the very basic concept and then I'll discuss the two different types of field of view. Alright, I'm going to use this orange here. So field of view has two components. It has a distance, which is something like this. So that's the distance. And then it has a field of view angle. And I'm going to use this color here. And that looks something like this. And I'm going to use this color to illustrate. Now, this is the field of view. This is now the field of view. Anything inside this is considered inside the enemy's field of view. So it has a distance to get that circular shape, that cone shape, and it has the angle. So this needs one, a distance, and two, an angle. Now, depending on how you get it set up, I recommend having the angle at the full width of the field of view. So I'll just set this at full field of view. So full field of view. So between here and here, that is the angle. Now your enemy, I'll use this color now. Your enemy has an angle of where it's pointing. This is enemy's angle. So what you need to do, you need to convert the field of view angle and divide that by 2. So that gives you this component. And now this component, you do the same thing. So for this component, you do the same thing. So you divide by 2 and it gives you that split. The left side of the field of view and the right side of the field of view. So that is the shared component of the field of view. That is the core concept. Now, the two different techniques you could use is utilizing the position of the player, and that is, I'll just use this color here. On my games, I set the center point as the position. I set that as the origin. So the position of the player will be the center point. That is the position of the player. So that is the player's position. So let me create a new layer here so I can go back to this. Alright. Okay. Let's redraw this so you can get a better understanding of the first technique. Alright, so we have our enemy, which is here. And we have our player. Let's put the player like right here. But let's make the player an extremely wide object. Something like that. And then it has a position of this. This is the position. And let's use this color for the field of view. So this enemy's field of view is going to look something like, it's going to go from its position, which is here. So it's going to look something like this. We're going to give it a very large distance and a high angle. So this is this field of view. Actually, let's make it a little bit smaller so we can illustrate what's going on here. Alright, that should be good, and that should be good. Now if we go here, give it a little bit of a circular shape to give it a cone illustration. So now this is the field of view. Enemy field of view. Alright, so right now I'm demonstrating the potential issue for the first type of test. Right now, this test would fail if the player is within the enemy's field of view because that position value in the center point of the player, this position value, is outside of the enemy's field of view. But we can consider this to be inside the field of view. So there's a few ways to make this a little bit better. It's not going to be fully complete because in this case the second option won't really test this that well either. And there's a few additional techniques that we'll look into when we discuss the advanced field of view. But for right now, if you want to only test the position value. So the enemy field of view has one distance, 2 angle. Okay. So let's put the actual algorithm in this code here. Alright. So for this option, option 1. So we'll test the position. If field of view distance is greater than player dot position minus enemy dot position Alright, so if the field of view distance is greater than the player's position minus the enemy's position, that will give us this. So that is the, let me put that in blue. Minus enemy dot position okay. So this green line here, that's the player's position minus the enemy's position's distance. Whenever we subtract one vector from another vector, we get a vector, so we just calculate the distance of that vector. So if the field of view distance is greater than, this is the field of view distance. So this is the field of view distance. So if the field of view distance is greater than the distance between the player and the enemy, it has a potential of being in the field of view. So that is the first check. So our second check is to get a source to target vector. So STT, source to target vector, is equal to player.position minus enemy.position. Now we need to get an angle, which is A tan 2 of the STT vector dot y, comma, STT vector dot x. So we just get the angle of our source to target vector. If angle, actually, let's put that in the standard coding color. If angle is greater than enemy.rotation minus field of view.angle divided by 2.0. Wrap that in parentheses here. Okay. So if angle is greater than that and angle is less than enemy's rotation plus field of view dot angle divided by 2.0. Okay. So let me discuss this now that we wrote it down. Option 1, we will test the position. So this is the player's dot position here. So we're testing the position of our player. If field of view distance, remember our distance is this part of our field of view, the cone part, so if the field of view distance is greater than the distance between the player and the enemy, which is this here. So if the field of view distance is greater than the distance between the player and the enemy, we have satisfied the first condition. The next condition is we need to satisfy the angle. So we need to get the source to target vector, and that is technically this. Source to target. So we get the source to target vector, which is the player's position minus the enemy's position. Then we calculate that vector's angle by using the atangent 2 method. Then we check to see if that angle is greater than the left half of the field of view. Alright, so let me illustrate that. So we're looking at step 2 now. Step 2. We're looking at this portion. If angle is greater than the enemy's rotation is this. It's half of the field of view. So the enemy's rotation minus half of the field of view. So that will give us the left side of the field of view. That will give us this side here. So if our angle is greater than that, and our angle is less than the right side. So if our angle is greater than the left side and less than the left side, it is within the field of view's angle, and we've satisfied condition 1, which means the player's position is within the enemy's field of view distance. So therefore, our player is within the enemy's field of view because we satisfied both conditions. Okay, so let me make a new layer here. Let me put this all in black. And let me discuss option 2. Okay. So option 2 is testing all edges. Testing all edges. So what do I mean by edges? So we have our player's object here. So our player's object has a bounding box that I'll illustrate in orange. Now this is a little bit better than just testing the position, but it's still a little bit not quite exact because we have all this empty space here and all this empty space here. But option 2 is testing all edges, which means, and I'll illustrate this in this blue here. Top left, top right, bottom left, and bottom right. So we test all those edges by repeating the same process 4 times. So we do the exact same thing we did when testing the position, but we do that 4 times for each of the edges of our bounding box. Now this option is only really beneficial if you have simple sprites, simple types. If you have an object that looks kind of like this, and it has a bounding box of like this, all this is empty space. All this is empty space. So this option 2 isn't really good in this case, or even this case, because all that empty space on the bottom right and bottom left, all this empty space, it's not very good. So use option 2 if you're dealing with simple types or have very small amount of transparent pixels in your object. Option 1 was used just to test the position of the player. So option 1 only did this test, only ran through once. Option 1 only ran through once. Option 2 4 times for all edges. Then when we look at field of view advanced topics, we'll discuss sides and things like that. Alright, so I hope you enjoyed this video. Stay tuned for the next video, which I don't think I've thought about yet. Let me look at the calendar quick. No, I think that's it for a while for the game algorithms videos. Alright, so thanks for watching, and I'll see you next time.